time of 1 week, so that we will be able to gather all the data. There could be some spelling mistake and all. So that can be all rectified within this particular 1 week of time. And definitely, all the participants, those who fill up the feedback form, will definitely going to get the certificate of participation of this particular event. We are just uh, we are just 5 minutes short to opening up this event. We are actually waiting for our guest speaker to join. I welcome once again all the participants, those who have joined for the event today. I'm very happy that participants from the different nooks and corners of the India has made it a point that they will be joining this event. And actually, it's a new topic that will all the faculties from chemistry, life sciences, physical sciences, and most appropriately the teachers must be getting the idea about this superheroes against superbugs. We will be soon joined by the guest speaker today, Dr. Anupam Herschel. And then we will proceed for the official opening of this event. This event is also live on YouTube. We are actually live right now also. So I'll just post the link on the chat also, so that if your student, those who are unable to join on the Zoom, they can also view this program or view this complete talk on the YouTube as well. I'm going to share the link on the chat I've just received the call from the guest speaker. She's having some trouble in joining because there's some internet difficulty there at her end. She'll be joining very soon. She's rectifying the issue from her end. She'll be joining in 5 minutes of time. Meantime, I'm very much thankful to all the participants for joining this event and patiently waiting for the speakers today, Dr. Anupam Herschel. Definitely, it is going to be a enlightening event for all of us because this is a very new thing that we are going to learn today. say that superheroes against super. I'm sharing the website of this SaS, that is superheroes against superbugs, so that we can get a glimpse of what exactly we are going to have today in our guest lecture. That is the talk that we have organized. This is a joint activity of LV High Institute from Hyderabad and British Society for the Antibiotic Resistance. Basically, they are more concerned with the teachers, those who are teaching at the school level and at the higher secondary level, that is from first to 12th standard, because this is the age group where we see that most of the antibiotics are consumed, sometimes knowingly and sometimes just by unknowingly, because some concerning the dose of that antibiotics. And from this is coming into the picture. We are joined by the guest speaker of today's event, Dr. Anupam Herschel. I heartily welcome Dr. Anupam Herschel on this event of a talk organized by IQAC of Vinayak Vignan Mahavidyalaya in association with LV Prasad Eye Institute, Hyderabad. I welcome you, ma'am. Can you hear us?
Thank you, Gajendra ji. Yes, I hope you can hear me.
Ma'am.
Can you hear me? Are you able to hear me?
Yes, ma'am.
Yeah. I'm so sorry. There was some.
I am actually able to hear you.
Yeah.
Okay, no issue.
Yeah.
Just a second.
Sure. I hope I can share my screen with your kind permission. I have done that. Yeah. So I hope you don't. If you have to share anything, just let me know. Yeah. Gajanan ji, I think we can just, Gajendra ji, I think we can just ask your office bearers to go ahead so that we don't keep people waiting.
Yeah, exactly.
I'll bail you out. Yeah, don't worry. Yeah, thank you, ma'am, for your valuable time. Yeah.
Good afternoon, ma'am. Good afternoon.
Yeah. Good afternoon, ma'am.
Yeah. Can we quickly just wind up the formalities, ma'am?
Sure. Please don't. I mean, don't worry at all. Please go ahead. Yeah. Please go ahead. Yeah.
So instead of wasting any time, I'll just directly jump on to the our presidential address. Unfortunately, the president of today's event, Dr. Alka Bhise ma'am, the principal of Vinayak Vignan Mahavidyalaya, she is unwell. So the IQAC coordinator, Dr. Suchita Khorke madam, will be giving the starting word for this particular event. Later on, I will introduce you, ma'am, and then we can start up with the event.
Sure. Thank you. Don't worry.
Over to you, Suchita ma'am.
Okay. Thank you, sir. Good afternoon, everyone. Honorable guest speaker, Dr. Anupam Herschel ma'am, respected principal of our college, Dr. Alka Bhise madam, all the teachers and the faculty members of various colleges and the head of the departments. It's indeed a matter of great honor for me to welcome all of you today for this talk, that is Superheroes Against Superbugs, organized by the IQC of Vinayak Vignan Mahavidyalaya in association with LV Prasad Eye Institute, Hyderabad. The Vinayak Vignan Mahavidyalaya was established in the year 2007 with a vision to create a future leaders of tomorrow by imparting education, knowledge, and the skills. The objective of the college was not only to impart theoretical education, but also to nurture our students and keep them rooted to the social culture and the ethics. Nowadays, in a college, IQC play a very key role in the enhancing the quality education and academic improvement of the college. So this is our small efforts to create awareness among the teacher, faculty members, and all the research faculty, so that teachers should take responsibility on their shoulder to raise awareness amongst the public and the student and make them aware about this important emerging issue. So about this seminar or the program, that is the Superheroes Against the Superbugs, is the public engagement initiative launched in 2018 with an aim to partner with the young people to raise public awareness and promote citizen and policy on the antibiotic resistance in India. So superbugs is an microbes such as bacteria, fungi, and viruses or the parasite that has grown resistant to most of the medication commonly used to treat the infection it causes. So its antibiotic resistance, it's rising to dangerously a high level said by the WHO. And in the US alone, more than 35,000 people die from the antibiotic resistant infection each year. And globally, that number may increase up to 7 lakhs. And by 2050, it may be 10,000 million. So people are calling it the silent pandemic, says by the David Weiss, that is the scientist. And so to keeping this view in mind, the IQC of our college has taken this initiative to organize this talk on a very important, emerging and burning issue, that is superheroes against the superbugs. I extend my sincere thanks to LV Prasad Eye Institute, Hyderabad, and Dr. Anupama Madam has given us this opportunity to conduct this program in our institute. Thank you, Madam. I hope this seminar or the talk will be productive and the next few hours will be enjoyable and fruitful to all of the participants. Thank you, Anupama Madam, once again, and welcome all of you for this webinar. Thank you very much.
Thank you very much, ma'am. Now, I promise, ma'am, Dr. Anupama Herschel, ma'am, the participant that you can see are the true listener of yours, because we have been waiting for you from almost a half an hour. Yeah, so I'm very much assured that these participants are definitely going to be definitely going to enjoy a fruitful event today. I would like to introduce the speaker of today, that is Dr. Anupama Herschel, in front of all the participants. Dr. Anupama Herschel, she is having a teaching experience of more than 19 years. She's having a research experience of 19 years as well. She has been actively involved in scientific communication and public engagement. She has been involved in also conceptualizing and developing the content on pedagogy. She has conducted many workshops. She is having an experience in the Indian Institute of Science, Education and Research, that is IISER Pune, as a consultant. She is also a visiting professor at Institute of Chemical Technology and for Pharmaceutical Biotechnology. She has done her undergraduate from St. Xavier's. She has done undergraduate. She's been a visiting professor for biotechnology for an undergraduate biotechnological courses at St. Xavier College. And her education is, she is a doctorate in biochemistry and molecular biology. She has done her MSc in microbiology and biochemistry. I welcome once again the guest speaker today, Dr. Anupama Herschel. Over to you, ma'am.
Thank you very much. And I must honestly admit there were 2-3 things that have fueled this delay, but I'm just going to keep that aside. And I'm very happy for all of you who are there. Let me be honest with you. This is not going to be a seminar. It's not going to be a session. This is going to be one of its kind of an online workshop. Okay, so I hope you are sitting with some pen and paper. I hope you are sitting with a glass of water, because I'm going to make you do a lot of work. And I'm very happy. There are 25, 26 of us, almost feels like a small closed room. You can keep your cameras on. You can keep your video, audio on, because I'm going to be asking you a lot of questions. And of course, as always, the chat window is open. I'm extremely thankful to you for your patience, because I know what it means to put up a session like this. So thank you to Vinayak Vigyan Mahavidyalaya for all their office bearers to having borne with this delay. Taking you ahead of here, I've tried to put my slides together in a manner where you will have to give me some answers, and we're going to be doing some exercises together as well. Why are we here? For the simple reason, well, we are teachers. We are either students or or we are probably, citizens who are part of solutions. We are handling students, whether they are as children at home or whether they are students in our classroom. I think all of this requires something called as higher order thinking skills, or something we call as HOTS. And a lot of us are faced with the situation where we come from official colleges or rural colleges. So if you want me to talk in Marathi, just send me a message and I will see. म्हणजे गोळा केलेला शब्दकोश आहे, पण मी प्रयत्न करेन मराठीत सुद्धा संवाद घालायला. So if there is any problem with the language, you can definitely get back to me. Essentially, we are all working together to look at methods, look at scientific literacy, look at this attribute which Sujita ma'am just mentioned, which is called as antimicrobial resistance. Now, essentially what happens when I say antimicrobials is they fall under 4 categories. Okay, now what are these 4 categories? These 4 categories are antibacterials, antivirals, antiparasitic agents, and antifungals. Okay, when I say antimicrobial resistance, when I'm talking of superbugs, I'm using a very broad term. Okay, and antibiotics or antibacterials work against bacteria. Example, a drug used for bacterial pneumonia. Now, I can see most of you or a lot of you are science teachers or science mentors. So if there's any value addition you want to make, please feel free. It's not my session, it's together. We are together in this. Antivirals are against viruses. Example, drugs for herpes, for HIV, and so on. Antiparasitic agents are against parasites, right? Drugs against malaria, drugs against a lot of worms and things like that. Antifungals are against fungi. These are drugs which are used for yeast infections, candida infections, and so on. So before I jump into this jargon and I start telling you what I've collected, what we have from different resources, and I make you do things, I want you to understand that antimicrobials is a very broad term which we use, which covers or takes all of this under the umbrella. म्हणजे जेव्हा आपण अँटीमायक्रोबियल म्हणतो तेव्हा त्याच्यात अँटीबायोटिक्स और अँटीबॅक्टेरियल्स, अँटीव्हायरल्स, अँटीपॅरासायटिक आणि अँटीफंगल्स included आहे. This is included there. Okay. Essentially, what happens is that when I am trying to use the term, the bulk of the resistance or the bulk of the reactions is coming from bacteria. So many a times, or most of the times, let me put it that way, when I'm saying antimicrobial, I'm hinting at antibiotics. I wish to put this on record and I want you to make a note of it. When I say antimicrobials, I've used a next slide now, which is obviously from the UKSL. So, it's defining antimicrobials, but essentially, म्हणजे जास्त करून किंवा ज्यादातर आपण जेव्हा antimicrobial हा शब्द वापरतो, when we use antimicrobial, we are referring to antibiotics that are used against bacteria. They are also called as antibacterials, but we don't use that terminology. So I want you to know that a large part of my talk is going to be focusing on actually antibiotic resistance, okay, or antimicrobial resistance. So please do not get me wrong. Antimicrobials are antivirals, antiparasitics, antifungals, antibiotics. But the bulk of the reactions, the bulk of the reference in literature is towards antibiotics, which are also called as antibacterials. Now, what are we looking at here? We are looking at medicines that are used to prevent and treat infections caused by microorganisms in humans, animals, and plants. Please note this. I'm not looking at a human system. I'm looking at a reaction. I'm looking at a resistance which is developing not only in humans, but also in animals and plants. Now, you must be wondering, why are we even discussing it like this, right? Why are we discussing what happens to plants and what happens to animals, and does it affect us? And I'm going to tell you, yes, it affects us, and it affects us in a very big way. And I'm going to ask you a question after this, but let me finish what I had in the slide. Now, antivirals are used for preventing or treating viruses or infections caused by viruses such as colds, flu, chickenpox, shingles, COVID-19, or HIV. I hope you can see my slides are quite updated. Antiparasitics are used for preventing or treating infections caused by parasites such as malaria, threadworm, head lice, and so on. Antifungals are used for preventing infections caused by fungi such as thrush, ringworm, athlete's foot, and so on. And antibacterials are used for preventing infections caused by bacteria such as cellulitis, urinary tract infection, tuberculosis, sexually transmitted infections like gonorrhea, and more. Okay, an antimicrobial drug works against only one type of organism. And what, according to, I will be sharing the WHO definition, is also that antimicrobial resistance, when the organisms change or mutate over time and get to a point where they no longer respond to medicines previously used to treat them. Now, this is the starting point that I want to take off. Yes, I want you to read it again. When the microorganisms change or mutate over time and get to a point where they no longer respond to medicines previously used to treat them. Okay, now my first question to you is as follows. Yes, I just said antimicrobials are used as medicines to prevent and treat infections caused by microorganisms in humans, animals, in plants. Now, I'm sure all of you are biology teachers, so you definitely know that they are used in humans. My question to you is, when we use these antimicrobials in animals and plants, does it affect humans? And if it does, how does it affect humans? Yes, my question to you is, when we use antimicrobials, we know about their use and their resistance in humans. Does it affect? It is definitely used in animals and plants also. So does it affect us when we use these antimicrobials for treatment of diseases in animals and plants? I want you to think and answer this question. Please don't give me an answer that I want. Give me an answer that you think is, according to you, is correct. Very good. So I have Dr. Kavita Pandey who says, yes, for example, antibiotics consumed by cattle and bees does enter the milk and the honey we consume. Okay, so that is, yes, they may come as traces in food. Very good. So I hope you can see that with these answers, it reaffirms that when you are using a medicine for cattle, when you are using medicine for plants, when you are using medicine for other systems, it is definitely entering the food chain in, which all of us are part of. And does that worry you? Should that worry you? How antibiotics, so you take a strip of antibiotic, you consume it, and then you just throw it away in the dustbin. I'm sure all of us, we are all Indians, so let's be very honest to ourselves. We consume the antibiotic, we throw it in the dustbin, we probably put it in the plants. I've seen many people who, take the antibiotic and, put it in the plants. Plant mein dal do. So do you think there is something for us to worry here? Do you think there is something for us to worry here if you read an article which says that, they are giving hormones to the cow to get better milk quality? They are giving hormones to the chicken so that the muscle protein is better. Do you think it should worry you? Do you think it should worry you? Or is it something ki chicken to humne boil kar diya, milk to humne boil kar diya, chicken humne process kar diya? Do you think it's something that you should worry? Do you think that's something that as a teacher, as a citizen, does it make you anxious? I know this is a little digressing from, the technical content, but do you think this is worrisome? Do you think this is something that you should pay attention to? Do you think it's something that we need to discuss? Yes? Any of you? You've definitely got the point that it enters our food chain. Yes, it definitely enters our food chain, and that is worrisome. Yes, thank you, Gajendra ji. He says bioaccumulation will take place. And once bioaccumulation will take place, that is where it's going to really, really worry us. And that is why I hope you can see, most people would wonder, ki, we are having medicines. Let us talk about humans. We already have so many headaches for our own self to manage. Why talk about animals and plants? But I think somewhere you need to understand that we are part of this entire system. We're part of this food web, we're part of this food cycle, we're part of this food pyramid. And therefore, it should definitely cross your mind when I say that these are going to affect, or these are used for treating infections in humans, animals, and plants. Okay. So what is antimicrobial, or where are antimicrobial drugs used? Well, I just said they're used for, fighting these different different agents. The more we use these drugs, please read these lines with me. The more we use these drugs, the less effective they become. And this problem is known as antimicrobial resistance. It means that microbes have developed resistance to our commonly used medications, meaning these medicines do not always work to treat infections. Although resistance is a problem with all antimicrobial drugs, antibiotics are used more than any other class of antimicrobials. That is why I said that all my slides would slightly, hint more towards antimicrobials rather than the other, agents available. But nevertheless, although resistance is a problem with all antimicrobial drugs, antibiotics are used. In fact, I would say they are abused, than many other class of antimicrobials, and need a more prominent position in the narrative. Okay. So what are the words that we are, likely to be using here? Antibiotic and resistant, extensions of how bacteria become resistant to antibiotics, and suggest how antibiotic resistance is developing and how we need to be concerned about this. Let's try and understand how antibiotics were discovered, how antibiotics is versus vaccines. I just picked up the slide from the PNAS. I hope you can see I've kept the references there in case you want to go back and read more about those articles. Vaccines and antibiotics licensed during the last century, showing the golden era of antibiotics in the 1950s. But I hope you can see that the golden era seems to be running out, right? And the limited pipeline of new antibiotics during the last decade is even more worrisome. So here you can see between 1930 and, about, let's say at the beginning of 1980, 1990, the antibiotic has peaked, and we're looking for more agents because resistance is developing in a very, very rampant manner. It's moving into a food cycle. And as Sucheta ma'am rightly said, it is a silent pandemic. In fact, when I'm reading papers now, I'm wondering, whether we are really paying attention to it in India, the kind of attention it has got internationally. But nevertheless, we are doing our best. But what I think is important now is what is thought in terms of this fellowship, or in terms of this society, is making citizens aware that this is something which is affecting us. This is something which is, going to be part of our food cycle. And we're going to have a next generation, or the millennials that we call, for whom, we will not be able to, leave any medicines. We will not be able to leave any treatments for them, and they will be at a complete loss. So before this bell rings at an alarming, level, I thought it's good to start interacting with a very learned audience. These may be teachers, these may be, students, these may be citizens, and wherever possible, if you can knit me as a part of your outreach, as a part of your Leo clubs, your community clubs. So that is why I said I'm actually indebted to Gajendra, because, I tapped so many colleges, but he was the first one. He said, no, ma'am, I'm sure we're going to have a lovely interaction. And therefore, I'm so indebted to Gajendra because he understood the intensity, and this is the way going forward. Now, what are the objectives of a talk or a session like this? What is antimicrobial resistance? Why antibacterial resistance is a concern? How antibacterials work? I will not go too much into the molecular biology. I have used cartoons to make it as interesting as possible for you. And I definitely want you to unmute yourself and also tell me if you can add any value to this session. What is the Indian scenario? Yes, what is NDM1? What are the strategies to contain this resistance? What is the treatment of some resistant bacterial infections? And of course, in the last, we'll have a summary and a talk with each other. So I'm just kind of, we're working on multiple fronts. We're all, kind of doing so many things right now at a time like this. And so I thought, what better than to ask you, do you think, can you tell me an example or some news or something that you've heard which talks or worries you that, ma'am, this is about antimicrobial resistance that I know and I would like to share with you? You could use the text box, the chat window, disposal of unused medicine and household waste, which goes in water bodies. Thank you, Dr. S.R. Chandani. That really, really adds value. And thank you so much, Dr. Beena, for those answers. Yes. Is there anything about AMR that you have heard or that you have come across, that you know, that you think, I should definitely tap onto? I'm so sorry, but I have just received message for the loss of a family member, so I'm looking at my phone. Please excuse me for the same. Yeah. Anybody, anything of AMR that you know? Anything about AMR that you know? Multiple drug resistance? Yes. Now this is burn cases. Yes, Kavita, that is such a value addition. That is such a value addition. How do you treat such people where they're already facing, so much of the infection, and all of it is kind of vying for each other to outnumber the other? Yes, they can't survive simply because of MRSA. Yes, thank you so much. Escape microorganism. Yes, thank you. That brings to the fore the class of microorganisms which are like, how you have the champions. So you have a superhero against superbug. So here you have a set of microorganisms which are very, very fast in evolving, or getting across the resistance to their own clan, to their own class of organisms. Okay, thank you for those answers. I really appreciate that. Okay, next. So, what the few new antibiotics that we've come, I said the early 80s, and I hope you can see that from 83, 88, 93 to almost 2012, which is the data which I've taken from the EU, you can see that very few antibiotics have been, in the fore. Have been in the fore. I hope you can see that very few new, antibiotics have been discovered in this phase. Okay, so I showed you an earlier slide where I said, I hope you can see that there was a peak for the antibiotics use, the way they were, kind of being used, the way they were kind of being, put to use against infections, and the way they were discovered, first line antibiotics, second line antibiotics, third line antibiotics. And now when you look at the actuals, you find that the number of antibiotics that have been discovered in the last 2 decades or so is worrisome. We don't have new agents there. And I think this is why I said that we are leaving the millennials with a large number of AMR strains, and, with probably a very difficult situation, because, I work with TMH, Tata Memorial Hospital, and I work with their TB center also, where we have a lot of our, working with doctors. And that is when you will actually realize that it is, it's a sorry state for the caregivers, which includes the nurses, the people who cook for them, the people who are, kind of interacting with them, and, the set of patients who are there in the same hospital. It's something that you all should strive to reach this out, whether it's through your clubs, through your interactions, to all your students and citizens. Timeline of discovery. I'm sure you all are all teachers, people in science, or if you don't have a science background, I put some names there so that you can see, sulfonamides were discovered, tetracycline was discovered, penicillin was discovered, vancomycin, and, you can see a progressive. So, when penicillin was discovered, after that, you can see streptomycin, chloramphenicol, tetracycline, erythromycin, vancomycin, ampicillin, and so on. Okay. Now, the thing is that this is just to give you an idea of how they were discovered, first line, second line, but that should also ring a bell that there was something that they were no longer effective. They were not delivering what they were supposed to, or in other words, somebody else or the microbes became smarter than them. Okay, and that is what is worrisome. So as defined by the World Health Organization, it's defined as microorganisms that are not inhibited. I'm using the word not inhibited by usually achievable systemic concentration of an antimicrobial agent with the normal dosage schedule and or fall in the minimum inhibitory concentration or MIC or range. You know how we learn cooking, right? How we learn cooking, we first put little of salt, then we put little of salt, then we keep asking our parent or mother, आई याच्यात किती मीठ घालायचा, किती मसाला घालायचा, and then gradually you standardize it. And once you standardize it, what you do, if you put a little more, what happens? It tastes odd, right? The salt is too much or the masala is too much, right? Now, what happens with antibiotics is something similar, that you cannot use them beyond that prescribed concentration. You cannot use them beyond that concentration. And that is why I thought, I know this is a little of maths and we all have a little of mathophobia as biologists, but what essentially I want you to see, what is written in red, is that they're not inhibited by usually achievable systemic concentration. So how many of you feel that, okay, you can't inhibit it by 2 milligram, let's increase the dose to 4 milligram? How many of you think that increasing the concentration may be, helping us going forward? Do you think that's going to really help us going forward? Do you think that's really going to help us going forward by increasing the concentration? So it's not working at, yes, thank you. That vehement no gives me an affirmation that no, increasing the concentration is not going to work, because right now it is inhibiting at that high concentration. But very soon, even at that high concentration, you're going to have no inhibition. At the same time, do we have good bacteria in our body? Do we have good bacteria that makes vitamins for us, gives us nutrients, ensures that our gut is completely healthy, ensures that our food is digested well, and so on? So I hope you remember that our gut, right from the mouth to the anus, has got a microbial, I would say, has a microbiome. Yes, has its own microflora. The oral microflora is different from that in the throat. The throat microflora is different from that in your gut. The gut microflora is different from that in your colon, and so on. Yes. So the next time you think, when you're doing research or you're having a lecture and you're preparing stuff and you say that I trust my gut, I'm trusting my gut, please believe me, the gut microflora plays a very essential role. And definitely there is a lot of, activities that it controls, and, that it is there. Okay. So moving ahead from here, just a little information about the evolution. I think you will not want to go through it. This is again just giving you a listing of when they were deployed. What I want you to see, however, is, while you had deployed this, when the resistance was observed. Can you see? Within 10 years, 1930, sulfonamides are discovered, and within 10 years, resistance is observed. 1943, penicillin is discovered, and please see the timeline. It shows that the resistance has arrived just or developed just within 3 years. So I want you to see this timeline is what is going to be very disturbing for us, which means that you are not going to be able to use these going further. So what is this antibiotic resistance? As I told you, I'm not going to be using, your very heavy microorganisms and a lot of you into microbiology, because that will scare you away. So I've used a very simple depiction here, where I've shown a microorganism, and very simply you put an antibiotic, and what should you expect? That the antibiotic will kill because it's an antibacterial, it will kill the organism. Yes, and therefore I have shown death here. Now, here is a little smarter strain. And what am I calling it? If you don't know what is a mutation, what is a mutant, it's perfectly okay. Let's call it a smart strain here. That's why you remember I will define superbug for you. So this is a mutant. Now, what does the mutant do? Can you see what it does? It's not affected when you apply the antibiotic. When you apply the antibiotic, it is not affected. Can you see it's ha-haing, or it's ha-haing the story? And what happens now is even more worrisome. It continues to reproduce and produce offspring that resist antibiotics used to treat it. So the whole purpose of applying the antibacterial has gone for a toss. The whole purpose of using the antibacterial or the antimicrobial agent has, defied its purpose, because the microbe is not affected. It is not inhibited. Its growth continues. And that is where, that is the reason why we are all here together. Okay. If there are any questions or doubts, just let me know. I would be happy to answer at this moment. Otherwise, we are good to go ahead. Okay. Anything that you think crosses your mind that you definitely want me to, talk about, I will definitely be doing it. Now, essentially, what is the truth? The antibiotics select out the resistant strain. I just told you 2 minutes back that can I use a higher concentration? You can try this experiment, give it as a project to your undergraduate students. You could give this as a project to your postgraduate students, that, you carry out your standard assay and increase the antibiotic concentration beyond the MIC. This is the minimum inhibitory, but increase it more than that. Establish a growth assay, and you will find that after a day, after 24 hours, after 48 hours, you will find some strains which are still growing. So what has happened is that the antibiotic acts as the limiting parameter, or acts as the selection parameter, that can you grow in so much concentration? And the microbial says, yes, of course I can grow. And it will show growth even in that high concentration of the antimicrobial agent. That is a little worrisome. What leads to this? What happens? Why does this happen? Faulty use of antibiotics or widespread use of antibiotics increases the probability of such selection. Antibiotic resistant strains appear to be more virulent because we cannot kill them or stop their growth. Okay. Now, I'm going to tell you a short story here, and I want you to tell me what went wrong in this story. Now, teachers, friends, please pay attention. I want you to tell me, what do you think went wrong in this story, or this small snippet? I would have loved to show you a video, but I'm narrating the story to you, trying to make it as interesting as possible. Okay, so a 14-year-old girl is playing in the house. Suddenly she starts sneezing. Please pay attention. Okay, I'm not going to repeat the narrative. So she's playing, and suddenly she's sneezing, and she says, "Mama, ai, maza khasa duktoy. My throat is hurting. My throat is hurting." Okay, and you know what her mother does? Her mother just picks up and says, "Last week only, my husband Baba had got a throat infection, so we had used this antibiotic." Please note, last week only, the child's father had got a throat infection. So he has this strip, the antibiotic strip. So she says, he is an adult, right? So I gave him one full one. So to the child, let me give half the medicine. So to the child, let me give half the medicine. Yes. And she gives proper lunch to the child. And then she says, okay, take half this medicine. And I will also give you some Zincovate or Abidec, so that, I'm giving you a vitamin supplement with it. Now, can you tell me what are your observations on this small narrative that I've given you? A 14-year-old girl child is having some throat irritation, is having a running nose, is sneezing, and the mother takes a call. Please mind you, if somebody has given the suggestion, don't repeat the suggestion now. Okay? So I want some very valuable observations. Fantastic. Dr. Kavita says, very good. Thinking that the cause of infection is same as the father is wrong. Very good. I'm looking for observations. If you want to turn on your audio and tell me the observation in Marathi, it's perfectly okay. Okay, in Marathi, Hindi, whichever language you're comfortable, I'm for it. Okay, we are here in a workshop. This is not a session where I'm going to talk. I need you to talk to me. It's unfortunate that we are doing this in the online mode. I would have loved to meet you either in Amravati or, in Sir's College, and, we would have had this session in person. Yes. So what is wrong in this small narrative that I have shared with you? या छोट्याशा परिस्थितीमध्ये मी जे तुम्हाला सांगितलंय त्याच्यात काय चुकीचं होतंय, किंवा तुम्हाला काय वाटतंय, तुमचं काय ऑब्झर्वेशन आहे, काय आहे जे थॉट तुमच्या मनातनं क्रॉस होतोय? डोज ऑफ अँटीबायोटिक हॅज बीन ऍडजस्टेड पर कन्व्हिनियन्स. व्हेरी गुड. Thank you, Dr. Sunani. That's such a valuable addition. Dosage can be just calculated as per age there. Okay. Okay, so there are two valuable observations, and I'm sure you worded it differently, but thank you very much. You've got a very high point. No problem, no problem. I'm just saying those who can unmute, no problem at all. Yeah, no problem at all. So I have two value additions. One, the same medicine has been given to the child. Dosage has been calculated. See, बच्चे को father को पूरा capsule देते हैं या पूरा tablet देते हैं, तो बच्चे को half दे देंगे. Because 14-year-old, na? So 50-year-old, 14-year-old proportion, ratio and proportion. We are pharmacists, we are druggists. Of course, mother is no all. My due respect for all the women members who are part here. I don't want to really sound otherwise. What are your observations? What do you think? It's okay to do this? Do you think it's okay to do this? She did it, right? And many of us do it unknowingly. Subconsciously, let's be very honest to ourselves, we do it. Probably the tablets of the father's prescription are left because he didn't complete the course. So let's see a third valuable point. Probably the tablets of the father's prescription are left because he didn't complete the course. So I have three valuable points, okay? One, judgment has been made. Second, same medicine has been given. Third, the father has not completed the course. That is why two of the medicines are left. Anybody else? Anybody else? So every time we get flu, we get sneezing, we get a throat infection. Are we sure it is because of a bacteria? I think somebody is unmuted. If you want to answer, please answer. Every time we get a throat infection, every time we get some hoarseness in the throat, some gale ka kharash, some sardi, khasi, is it because of bacteria?
No, it can be tonsillitis also.
Yes, thank you, Dr. Beena. That is such a value addition. Also, you cannot be sure that it's the same organism that is causing it.
Yes.
And thank you very much. Ma'am is saying again, ma'am, this is what I wanted from you, from such a learned audience. It can be viral. It can be viral. So can you see how you have gone paradoxically wrong? You're using something which is an antibacterial for something that is not a bacteria. It could be viral. So having that antibiotic is not going to do anything to that viral infection. All you need to do is have some warm food, take some gargles, give some rest, get some good sleep. But what have you done? You have taken an antibiotic, taken the ratio and proportion, being the pharmacist, being the druggist, being the medical practitioner, with due respect that you are the mother of the child. But that decision can cause a great deal of harm to the child. Okay. And as Beena ma'am has just said, Kavita has also endorsed that it could be viral. And if it is viral, taking an antibacterial for a viral is absolutely, again, a big, gross mistake. Do you agree to that? Taking an antibacterial for a viral infection is something that is, it's unforgivable, it's unpardonable. It's unpardonable, right? So, yes, so this is what, is essentially, I'm trying to drive home the point here. That this is not that it doesn't happen in my house. It doesn't happen in your house. It doesn't happen in our neighbor house. It happens with all of us. And somewhere we need to make note of this, that we have to stop doing this. Kavita just pointed out that, ma'am, I think the course was not done fully. The course was not done fully, because if it had 10 tablets, you know what happens typically? Second day pe, doctor has said, subah lena hai, sham ko lena hai, subah lena hai, dopahr ko lena hai, sham ko lena hai. Arey, I am feeling very good. I'm going to office today. And I'm being very honest because I have a partner too, so I understand. I'm feeling very good. I'm absolutely okay. I'm going to office. Abhi lene ka zarurat nahi hai. And then when he comes home, I ask him, have you taken the medicine? No, it's not needed. Fever nahi hai, jukham nahi hai, gala bhi theek hai. I'm perfectly okay. Do you realize what has happened? 2 tablet बच गई, 3 tablet बच गई, जबकि it should not have remained at all. It should not have been left out at all. Because if it said a course of 5 days and there were 10 tablets, then you should have completed the dose. But honestly, this is what my mother also does. So I'm being very honest. I'm also party to this. I'm also culpable here. Yes, अभी मुझे काफी ठीक लग रहा है. I'm just feeling fine. नहीं, और वो antibiotic लेने से और weakness आएगा. So not needed. Suddenly you seem to be the WHO head. You know everything. You know everything, right? And that is how 1 or 2, tablets are left. Thank you, Swapnil. Swapnil says the course has to be completed. Yes, the memory cell formation. Swapnil, thank you so much. I'm not going to go so much into the molecular level because I believe there are teachers of different subjects also. So I don't want to really, they will say, Anupam ma'am is teaching molecular biology, but nevertheless, yes, there is something that your body remembers. There is something that your body remembers that I have seen this. So ye to manage ho jayega. Yes. And you have to also understand every time, supposing now this child, this case that I have shared the story with you, if it is viral, what happens to the friendly bacteria? What happens to the friendly bacteria? Friendly bacteria are there in the mouth, friendly bacteria are there in the throat, friendly bacteria are there in the gut. So what happens to those friendly bacteria bichare? Wo to aise hi mare gaye na? They are also killed. They are also killed. So has that taking of that antibiotic helped you help your throat or help the sneezing? The answer is a big no. It has not helped at all. So imbalanced good and bad bacteria, eubiosis. Yeah, thank you very much. Saving the tablet and money tendency of people is very harmful for their body. Thank you, Swapnil, for that value addition. I'm going to use that tagline somewhere, as a slogan or something. That is exactly why I thought I should tell you that I'm not a saint here. My family is not practicing sainthood. I have also been doing this. But the realization, being educated, always thinks, no, if you're not eating, just let me do. And I'm being very honest with you. When I keep medicines in a separate bag and I'm looking, where I can donate it, either in Lions Club or something, people laugh at me in my society that, ma'am, you recycle everything. And that is not the way it is. It's not wrong, because I just can't throw it away in the dustbin. I can't put it in a plant and say, jo hoga dekha jayega, let's see. That is not the way it is. Abroad you have something called as a you have tablet banks. Maybe Gajendra ji can take this up in his college, or you can take this up in your areas. How you have a small box. If you have anything which is left out in your house and you're not consuming it, please come and put it here. At least it ensures that every household, if there's some medicine that you've not taken, that you're not likely to take, that you've kind of done away with, yes, medicine take back program. I think a lot of places, the Leo clubs, the community centers, they do this. Yes, so you need to generate this kind of awareness where you ask people to come back and give it to you. Just put it in that box, and then you can sort it, give it to a medical practitioner, give it to some charitable of like, for example, we have the Lions Club of a Lions Club hospital here in Chembur. So they take these medicines. They have a pharmacist who will properly make a note, that Anupam ma'am has given this, and he will write their expiry date. He will actually give me a receipt. You could start a center like this. You could think of. So that's why I said, this is not here that I'm here to teach you. This is something that we together need to build this, because this is a silent pandemic. And believe me, I'm not using numbers here, but the numbers are shocking. And I think we all agree the way, thank you, Anjana ma'am, for, that value addition. And the way it is moving, and the way we are in a country where a lot of things go undocumented, COVID deaths are not reported on a dashboard. It's very difficult to get out data. I think what's important is that we try and initiate these programs in our own localities, build these communities as a part of our outreach or other. And, whatever help you need, of course, we are there to help you as fellows and see, how we can reach it out better. So from this narrative, what is it that we can draw home? One, complete your dose if you have been prescribed an antibiotic. That is rule number one for any medicine. You please don't become the doctor. There is somebody who has studied medicine. There's somebody who's done their degree. They've studied pharmacy. They've studied etiology. They've studied, a whole deal of medical, clinical biochemistry, and therefore they know it. Second, any kind of infection cannot be classified as bacterial infection. It could be viral. Yes, so you need to understand using an antibacterial for an antiviral is as simple as dialing the wrong number. You needed to dial a different number and you've reached across to a wrong number. It's as simple as that. I don't know how many of you still have landlines, but when we were young, we would have landlines. And, if you had somebody who would call and say, is XYZ there, is ABC there, you would say, no, wrong number. And then repetitively, you would get calls on that number, right? So you have to learn to say this practice that this is not done. Third, please do not decide on your own what medicine to give to your children, to your parents, to your spouse, to your cousins, niece, nephews at home, especially in weddings, in community functions. Oh, don't worry, just take this tablet, you'll be fine. You need to see a medical practitioner. You need to see a medical practitioner to ascertain whether they have to give in first line, second line, third line, whether it's a throat infection, whether it's laryngitis, it's pharyngitis, or it's, something that a medical practitioner has been trained to identify. It can be a GP where your children have been, looked at right from the day they were born. It could be a pediatrician, or it could be, a better surgeon or somebody or a physician, like we call them, who can look at you. Fourth point, okay? Whenever you are using an antibiotic, whenever you buy an antibiotic, so I'm showing you here, a Caldi capsule, okay? Now, when I remove this and I show you, you may not be able to see it very clearly, but whenever you buy an antibiotic, can you see it doesn't have a red line? It doesn't have a red line. Whenever you buy an antibiotic, the strip has a red line. You know what that red line means? The red line means that this can be prescribed only through a prescription. It cannot be taken like that. So the next time somebody does this, please try and remind them that this is not to be taken without a prescription. So, you just go to the, in fact, I can tell you, I can just now walk to the pharmacist and tell him, I need azithromycin, and he will immediately say, Madam, kitna do, 5 do, 10 do. Can you imagine? So very clearly the pharmacist has been defined. Yes, thank you, Swapnil. Swapnil says, yes, these are Schedule H drugs which need to be purchased only on a prescription. Now, I don't want to go into the system. I cannot change the system, but I am the change that I wish to see. So I'm sharing my know-how and trying to spread this awareness so that you can take home the message, and build it better. I'm sure you'll do a much better job than probably I'm even trying to do. Okay, before we move ahead, yes, thank you, Anjana. That's really very kind of you. Okay, before we go ahead, there is one set of friends that these bacteria have, and they are called as plasmids. They are called as plasmids. I hope you can see this cartoon here. In the cartoon, the person with coat is saying, "Can you listen? Come here, come here, come here. You want to be a superbug? Just take this DNA, put it in your system, and you will be a superbug." So there are certain extra chromosomal genetic elements that can replicate independently and freely in the cytoplasm. These are called as plasmids, and they carry, now you know how genes are named. They are named on what characteristic they give to the cell, right? So they carry genes which are called as R genes, and these plasmids are called as resistant plasmids or R plasmids. Yes, there is definitely a horizontal gene transfer. There is a transfer mechanism. I will just touch upon it a little at the end of my session. Okay, so plasmids which carry these genes, what genes are these? R genes are called as R plasmids. And these are like, how it is in your WhatsApp group or how it is in your class. You tell somebody something, that Kavita ma'am today is giving the notes, it is at the Xerox fellow, then Kavita ma'am doesn't have to do anything. Everybody goes straight to the Xerox fellow and just tells them, final year unit 2 ka notes chahiye. Did you see what has happened? Final year unit 2 ka notes chahiye. They just go to the Xerox fellow, or they just go to the printer, or they just go to the vendor and they just pick it up. Similarly, these bacteria are very smart. They will immediately take this R plasmids. They're immediately transmitted from one bacteria to another, and much of the drug resistance encountered in clinical practice is plasmid mediated. It is plasmid mediated. And what happens when I have the notes, or I have a Xerox copy, like for example, I have a Xerox copy of Lineager, okay, or I've got a second-hand copy of Lineager for 80 rupees. What happens next? I tell everybody in the class, Are, go to this store and pick up the Lineager for just 80 rupees. They have very nice copies that are there. Now what has happened? The entire class has Lineager. Now having a Lineager, having a Conan stamp, having an Anand Narayan or a textbook is good. But having a resistant plasmid, please think about it. Yes, having a resistant plasmid is putting the entire population to a great risk. But what the bacteria do? Oh, you have the plasmid. Can I also have a copy of the plasmid? And this is how the entire class that you thought had, a textbook is now an entire class of your naughty bacteria, smarty bacteria that have got the plasmid, and that plasmid is what is going to give them the antimicrobial or the antibacterial resistance. So those 4 reasons that I outlined before this using a narrative was for you to understand that this is something really serious and this is something really big. And that is why WHO and other bodies are working so closely towards this. Now, what exactly happens when a bacteria develops antimicrobial resistance? Yes. Now, antibiotics normally enter the bacterial cells via the porine channels. I've given it a very schematic look. Okay, this is not how it looks in the cell. It's quite complicated, but if it ain't simple, I don't want to learn, right? So antibiotics normally enter through the porine cell. So this is the antibiotic in green, and this is the cell wall. This is the interior of the organism. I hope you can see the porine channel by which the antibiotic is going to go. See, so this is the antibiotic. It goes from here and it enters the interior of the organism. Okay, now let's see what happens. What is the meaning of porine loss? What is the meaning of porine loss? So when antibiotics enter, the bacterial cell via porine channels, if this porine channel itself is lost, what will happen? The antibiotic will not be able to enter through the cell wall into the interior of the organism. Can you see now what has happened? I have now become smarty, isn't I'm a smarty bacteria, right? So when I say please, I'm not naughty or smarty. I'm just trying to tell you about the bacteria, which are the superbugs, trying to reach you out that why we are calling them superbugs and why and how they are superbugs. Okay. So now what has happened? I have just changed the shape of the porine. In my earlier slide, please note, the porine was circular and the antibiotic was easy to go through the porine. But now it has changed shape. So the antibiotic is barely able to manage to go inside. Now what happens? The antibiotic cannot go inside the organism and therefore the organism does not get killed. This is an antibacterial, right? The antibacterial is not able to enter the bacteria. Do you think it will be able to kill it? It's not able to kill it. So this is one of the mechanisms, just one of the mechanisms by which it has modified the porine in the cell wall or the channel by which the antibiotic comes within the interior of the organism. And by just doing a very simple change into the new porine channel, can you see I have both the old and the new porine channels here? See, I have the old porine channels and I have the new porine channels. The new porine channels are not going to allow the antibiotic to move inside the interior of the organism. What other way can happen? Right? Now, structurally, you could modify the antibiotic target site. Structurally, you could modify the antibiotic target site. It's, how sometimes you see people, you know them, but they don't seem to recognize you, especially in a market or in a public place. And you are saying, I know this person, and that person is like, no, I don't seem to know you. So this kind of non-reception, right? Again, here, the site gets structurally modified so that it doesn't recognize the antibiotic. The antibiotic comes here, it goes there, but it does not recognize the target site. Again, this is one of the reasons why the antibiotic is unable to move from here to the interior of the cell. Okay, now again, can you see it has been blocked and therefore the antibiotic cannot now go inside, or it's no longer being able to bind to the channel and therefore it cannot go inside the channel. Okay, so I hope you understand that. Antibiotic inactivation. Can you see antibiotic inactivation? Now, in antibiotic inactivation, the antibiotic is in green. Yes, and there are some things that are there in pink. Yes, there are some things that are there in pink. So, inactivating enzymes targeting the antibiotics. Inactivating enzymes that are targeting the antibiotics. That means as soon as the antibiotic comes, the inactivating enzymes will attach to this and they will inactivate. So nothing has happened to the binding site here. See, the binding site is perfectly ready to take in the antibiotic. But now what happens is this binds to the antibiotic. This binds to the antibiotic and therefore it will actually inactivate the antibiotic. It will actually break down the antibiotic. Yes, thank you. Beta-lactamase is an example which inactivates penicillin antibiotics. Thank you so much, Kavita. So can you see it is actually inactivating the antibiotic? And now can you see what has happened? Now can you see kaboom? Means it has broken down the antibiotic. The whole purpose of the antibiotic to go into the interior of the cell has been defeated because now the organism, which is naughty and smarty, has made an enzyme which says, I can easily manage you. I can easily break you down. And it completely destroys the antibiotic, or the antibiotic is, unable to show its action because it gets altered. Can you see the shape has changed from a circular shape? It has now become a, oval shape. And therefore, it can no longer enter the interior of the organism, forget showing action for the organism. Okay. So what do you think are, the common causes that essentially lead to antimicrobial resistance? I've tried to list them down as a flow chart. First is overuse. Yes, overuse for any, incorrect diagnosis. prescription of antibiotics for viral, for seasonal flu, for just a sore throat, for just a little rhinitis, which may not even be attributed to a bacterial infection, or even, putting 2 or more antibiotics together, unnecessarily long course of antibiotics. This is what can go wrong at the end of the physicians. This kills the resident bacteria, out of which some are survived. Many of them will pick up the antibiotic resistant genes, and passing of these genes to the pathogenic bacteria will actually help them in developing antibiotic resistance. So I have not said that just we are making mistakes, but many a time physicians also, overdo their evidence-based information that they have in terms of prescribing long dosages, in terms of prescribing 2 antibiotics together. I mean, that is like difficult for even the system to take, right? And without proper diagnosis, that means whether you're not sure whether this is really an antiviral, without even properly understanding whether this is an antiviral or some other agent that is causing it, to immediately prescribe and give an antibacterial. Okay, so that is overuse by the physicians. The next one, misuse. Yes, we already discussed this as a case study of the 14-year-old child. Not finishing the full course of antibiotics. Okay, I'm fine on the second day itself. I don't need to take medicine. Yes, because as a layman, I don't know that antibiotic has a course. I have not had, like for coronavirus, how we, phone uthao to bhi we have a mask pehniye, haath dhoiye. Like that, I have not been told that whenever you're prescribed a medicine, pura dose khaiye, pura ka pura uska regime complete kijiye, khane ke baad kaha hai to khane ke baad khaiye. I have not been told. I have not been mentored. I'm not aware that it needs to be done. So not finishing the full course of antibiotics, misuse, right? Oh, this has worked well with me. Papa, you're unwell, please have this. Child is unwell, please have this. Are you understanding? It can have serious, very serious implications. Yeah, thank you. Can you throw some light on challenges in efflux pump inhibitors as antibiotic adjuvants? Definitely, sir. I will see if I can just talk about it a little towards my talk. Some bacteria are not killed. Okay, because you've not completed the dose. The dose was given so that all the bacteria that need to be killed, that are causing the infection, are killed. If they are not killed, some bacteria get left out and they develop resistance for future antibiotic treatment. Okay, so we had in terms of diagnosis, we had in terms of, misuse. Over-the-counter antibiotics. Are gale mein thoda kharash hai, I'm traveling, let me just pick up, azithromycin. Let me just pick up erythromycin. Over-the-counter medicines, no prescription, and the pharmacist also doesn't ask you that, do you have a prescription for this? Acha, you want this? Kitna do? And he gives it. So that leads to inappropriate use, which also causes overuse and misuse and development of antibiotic resistance. I don't know if you are sure about this or if you know it, but at least in cities, the pharmacist may ask you for a prescription. But I have seen in rural areas, I have seen in my own natives in Haryana, Uttar Pradesh, you just go to the counter and he treats you as if it's a general store. What do you want? And in fact, the pharmacist is also the doctor there. So you just go and tell him, कि थोड़ा गला खराश हो रहा था और, सर्दी खांसी नजला हो रहा है. Immediately वैसे आप ये ले लो, 2 दिन में आप ठीक हो जाओगे. So the pharmacist has also become the medical practitioner, that he's giving you antibiotics. And obviously that he's doing it with you, he must be doing with scores of people who are taking those antibiotics. Okay. Healthcare workers. So in healthcare workers, what happens is in the hospital, they are exposed to these infections. They may not be following infection protocols. There are designated areas where they need to, change their clothes. They need to handle in terms of sterilizing their hands, sterilizing the containers that are being used, sterilizing the instruments that are being used. A slight, lapse may cause the infection to spread. So not realizing that we are part of, a system like this, and therefore we need to take utmost care to ensure that the infection doesn't spread. And here the resistance is transferred by swapping of genes, and we're all very well aware that horizontal transfer really facilitates this. Hospitalized patients, patients with compromised health where their immunity is much lower, patients who have been exposed to pathogenic organisms. Somebody at the beginning of the talk said burn patients. Yes, burn patients. Increased use of different antibiotics, rapid development of leads to rapid development of resistance, in these people. So you have to understand that they've come there for the treatment of some particular disease, but they are immune compromised, they are malnourished, they are severely, not well fed, and therefore they do not have that kind of health parameters that will help them or support them to go through the treatment, and therefore they become very, very vulnerable to these kind of infections. So increased usage of different antibiotics by the physician obviously leads to rapid development of resistance. Now comes why we should be concerned about animals and about plants. Well, in animal feed, many a times they don't want the animal to fall ill. So ideally, the line of action would be, yes, animals also fall ill, cattle fall ill, poultry fall ill, and you have veterinary doctors, you have veterinary surgeons who are supposed to take care of them and who do take care of them. But what essentially happens is, because of the pressure of the market, because of the production, because of different parameters, people add antibiotics in the feed. They mix antibiotics in the feed so that the animal does not fall unwell, does not succumb to infectious diseases. Right? This is like, a prevention is better than cure, but not with reference to antimicrobials. So because they want the poultry to have good health, because they want the poultry to not fall ill and the production levels to go on, many a times this happens in the unorganized as well as in the organized sectors. The antimicrobial is mixed with the feed, and then it is given to the animal to consume to promote to promote growth, not realizing that that animal has got a microflora. Yes, and that animal will now have resistant organisms which will spread to humans, which is something that probably has not been recognized by these sectors. Okay, so running through this again, we kind of looked at inappropriate use, increased empiric polyantimicrobial use, overuse, inadequate dosing, and lack of current knowledge and training. So let's begin with what examples we know, or like I asked you in the beginning, which are what have you heard about antimicrobials? What have you heard about multiple drug resistant bacteria and so on, right? We all know every day in the newspaper, there is at least one article, which talks about multi-drug resistant tuberculosis, related RMSA, and so on. What is this multi-drug resistance? This is combined resistance to rifampicin and isoniazid. Now, anybody who has studied a basic course in biology or in microbiology or in clinical biochemistry would know that this is the line of action for the treatment of tuberculosis. So imagine you now have combined resistance, not just one, but resistance to both. And this is what is making what we call MDR, or multi-drug resistant TB. It's almost turning out to be a holocaust. It's almost turning out to be a holocaust. I can tell you, being an alumni of Nair Hospital, we had the TB hospital right at Satrasta, and believe me, those doctors who got duty there, or those doctors who got internships there, used to have a tough time swapping their duties, or getting people to take up their duties. So while their work span, or their time span for them to work on that duty would be 1 year, they would end up working almost 1.5 2 years, because they wouldn't find replacements. And that would make things so miserable for them, both personally and physiologically, in terms of their health. Okay. Of course, now they have redone that hospital with a lot of infrastructure changes coming from the government of Maharashtra. But I'm talking of a time when I was doing my PhD, and this was 1993 to 98. And it was a horrible sight to see, because my brother, being a clinician, he was deputed there. So I can tell you, it's unbearable. I mean, when you see that, you just feel that, thank God, nobody should ever get tuberculosis, and definitely never succumb to something called as MDR. But the way it has been kind of taken up on a rampant footing by the health ministry, both the central government and the state governments, and now of course the hospital has a completely different look, with a lot of air purifiers, with a lot of positive pressure in the rooms, in the treatment rooms. The treatment protocols have been modified, the doctors have been empowered, the medical staff has been trained, but essentially the damage has seeped in far too much. Also, we are in the city, so we don't know what happens in either in rural Baramati or in Sangamner or in Nagar. It's very difficult to predict. I always feel We in city are the 5% of the population which gets all the perks, and we think that this is the country. This is not the country. The country is actually when you go into the rural areas, when you go to Nagar, when you go to Bodegaon, you go to Shirur, you go to Shegaon, you go to Jean, Bhiwani, Muzaffarpur, Ramnagar, Rampur. When you go to the local, when you go to places where the agrarian economy, the farmer lives, or the bulk of the population lives, and that is the time you will realize that reporting, having a primary health center, having access to a hospital, having access to a vehicle to reach a hospital are something that is unimaginable. We are the ones who are really, really privileged, and I think that puts more responsibility on us to outreach and reach this awareness to other areas where we can probably try. Okay, this is an extensively drug-resistant tuberculosis form, which additionally acquires resistance to a fluoroquinolone and one of the 3 injectable second-line drugs. So either it could be capreomycin or kanamycin and amikacin, and this is seeing a very steady rise in the patients. So just see, this party together, that this is combined resistance for rifampicin and isoniazid, which is the ICMR protocol for treatment of this disease. It's also, additionally acquiring resistance to a fluoroquinolone, which was the next line, and to the 3 injectable second line of drugs. So it's something that's really, that's why I said, every day you open the newspaper and you're bound to find at least one article. So my request is to a lot of people who are in the Northeast, to a lot of people who are still in other parts of the country where this is still not rampant, where this is still in the nascent stages, by spreading the awareness and by by reaching out to a large population from different forums is definitely going to help you and the next generation in combating this kind of a infection. I'm not so sure if you've heard about this New Delhi metallo-beta-lactamase. Why is everyone concerned? Well, this is something that, Delhi takes pride because it also has its name. There are currently no new drugs in the research pipeline that aim to stop NDM1. Okay, so while it is called as NDM1 and it doesn't seem to be having anything to do with us, NDM1 basically means New Delhi metallo-beta-lactamase. Okay. To date, some strains of E. coli and Klebsiella pneumoniae are known carriers of the gene, but the gene can be transmitted from one strain of bacteria to another, as Kavita rightly said, which is called as horizontal gene transfer. It's like, hey, buddy, I have this. Why don't you also have it? Because, it'll be easier for you to navigate through this paper or that paper and things like that. Okay. What is horizontal gene transfer? I have given in a very simple method here. The plasmid is there. Can you see it is extra chromosomal? That means it is different from the chromosome. Not using too much of, what is conjugation and things like that. It establishes, a conjugation, a tube here. It establishes a connection in case you're not from the life sciences. And from that, I hope you can see what's most remarkable is that the donor retains a copy of the plasmid and the recipient now has a copy of the plasmid. So it's not as if I'm losing the plasmid, I'm giving you a copy of the plasmid. So you are also now resistant and I'm also resistant. And together we can either break the antibiotic, not allow it to enter, or, do whatever the needful to ensure that we are now resistant to the line of antibiotic that has been used against me. The recipient, that is now, see here, the recipient may even integrate the plasmid into the chromosome. That means every time the bacteria divides, the plasmid is going to be dividing with it. Okay, so can you see retaining it as a plasmid? Well, then it's a plasmid. It may replicate, it may not replicate, but having it integrated in the chromosome, what do you think once it's integrated in the chromosome? What happens once it's integrated in the chromosome? Any takers? Once it's integrated in the chromosome, the chances of its replication are higher because every time the bacteria divides, the gene is also going to divide. The resistant gene is also going to be dividing. Okay, so that's something that you need to remember here. Okay, now, okay, this is something that again, how do we combat patient-related poor adherence to dosage regimens? This could be poverty, that do capsule I'm feeling better, let me keep it for next time. Lack of sanitation is something that I'm going to deal exhaustively in my next few slides also. Lack of education, self-medication, misconception. I'm just fine. I don't need. And how does it help? How can you help? You can help by patient counseling and by initiating or being part of awareness programs. Why resistance is a concern? Well, resistance is a concern because resistant organisms lead to treatment failure. That means you're treating somebody for the disease and the treatment fails because the person is not responding. There is increased mortality. Most MDR results in death, and it is very painful, both for both the person, immediate family, and the distant family to cope up with this. Also, what happens is because the person has had a MDR strain, the immediate family is also has been in contact with that person. That makes them very vulnerable. So you have to understand that this is not that ends with the patient, but it continues to even affect the immediate and the distant family of the person who has been affected. Resident bacteria may spread in the community, right? Low level of resistance can go undetected. Added burden on the healthcare costs. I'm sure all of us have seen in the second wave how the healthcare infrastructure in India exists. I really don't want to tag the line of for or against it, but I think we know how our public hospitals operate. Having myself been from Nair Hospital and having finished my PhD from there, let me tell you, it's in a typical OPD from 9 to when I was working in KM Hospital in their adverse drug reaction under Dr. Nilima Shirsagar, in a typical OPD, which extended from 9 to 12, I used to be there with her for 350 patients, collecting the blood for these patients to check the eptoin, cardinal, and carbamazepine levels for these anti-epileptic drugs. So can you imagine, from 9 to 12, 350 blood samples, and it would go as mechanics, where you just put the band, look for whether it's a small child, it's a big person, just tap the vein and draw the blood. So I hope you can understand that the kind of burden it puts on the healthcare is tremendous, especially for a country like India. It's absolutely unaffordable because we hardly spend point some percent of our GDP on our healthcare in terms of our healthcare budget. It threatens to take you back to the pre-antibiotic era, where there is absolutely no treatment available and you're struggling to combat different diseases and infections, and there is definitely a selection pressure which works. Okay, so that's something that nature starts selecting those who are the smarties, and those who are not are left out. So this is something which is very worrisome. This is something that cannot be predicted from where we are, but I'm sure there are people in working with machine learning and NLP programs who are trying to predict and use these specifically in medicine. As one of you just mentioned, antibiotic resistance is when it is, when a bacteria that is used to be killed by a drug isn't affected by it anymore, and therefore it becomes a superbug. And one of the examples that I thought you should see is MRSA, which is methicillin-resistant Staphylococcus aureus, or S. aureus, as we commonly call them in our lab. The bacteria called Staphylococcus aureus that isn't killed by the antibiotic methicillin. I hope you can see this infection in the hand of the subject. I've kind of taken a picture of the bacteria also, and I hope you can see the smarty naughty bacteria here, which is ready to open the capsule of methicillin and consume it, and says, haha, I'm not going to be affected by it, so you can do what you can, which is a very dangerous proposition. This happens. There are wards, and I can't share the trauma of especially burn patients, which have to really go through this and bear this. Okay, so what exactly happens when I'm saying they're developing resistance? What exactly is happening there? So I just thought I'll pick up this small graphic which will kind of help you and tell you that this is the way things work. A natural population of bacteria has some that are susceptible and some that are resistant. So it's not as if all of them have suddenly become okay. There is natural pressure, there is selection also, but within the population there may be just one bacteria that may be resistant. Within the bacteria there may be one bacteria which has developed mutation, and therefore it is capable of taking this further. But what is happening is it's not being facilitated, it is not being selected. So here you can see there are happy faces, there are not so happy faces, and there are definitely some frowning or really scary faces. Okay, so it has got some which are resistant, some which are susceptible. Okay, now what happens when I use the antibiotic? You start taking an antibiotic. Now, what happens when you start taking an antibiotic? When you start taking the antibiotic, essentially, can you see some bacteria have got eliminated? Can you see some bacteria have got eliminated? And what are they? The susceptible or the weak bacteria die first. I'm going back to my slide. Can you see? There are certain weak or susceptible bacteria, and as the antibiotic treatment progresses, those susceptible or weak bacteria die first. What happens next? You keep taking the antibiotic and more bacteria die. You keep taking the antibiotic and more bacteria die. What next? Yes, until eventually only the resistant bacteria are left. Yes, so you first take the bacteria, the susceptible bacteria go, the next one more bacteria will go, and then only those which are resistant will remain. So I told you, no, the frowny ones or the not so good looking ones are there. Now what happens when you stop taking the antibiotic? When you stop taking the antibiotic, the resistant bacteria reproduce. When you stop taking the antibiotic, the resistant bacteria reproduce. Can you see there is a distinct increase in number? Yes, they're increasing in number. And as they are increasing in number, now there are loads of bacteria or lots of bacteria or a population of bacteria which is susceptible or resistant, which is now resistant. Okay. And this resistance, what happens when I take the antibiotic again? So now I have an infection after a few days or after a few months. And now what happens when I take the antibiotic? If I now take the antibiotic, see what happens. Nothing. Nothing at all. Why? Why? Because the bacteria are now resistant to what you had, bacteria that to the antimicrobial that you had taken. They have developed resistance and therefore now they're not affected. So whether you take the antibiotic or you don't take the antibiotic, it's not going to bother them. They're anyway not going to succumb to the antibiotic at all, which means that now the infection that you have cannot be treated by the drug or the medicine or the antibiotics that you are consuming. Okay, so I have a small exercise for you here. Quickly put this in order, and if you want to use a schematic or something to show me, you can definitely use that. Okay, so complete the storyboard to show how antibiotic resistance develops. If you want to draw your own schematic, I'm fine with it. Okay, otherwise I have given you, A, B, C, D, E, F, G, H. Can you just put them in order? Can you just put them in order quickly so I can take a quick water break? Anybody who has been able to draw a scheme or something that can be shared, you can quickly take a picture and share it on your phone, or you can just probably just show it to us on camera. Is there something wrong with this statement? I just showed you a set of graphics. Is there something wrong here in the order in which things are happening? Okay, I'm just giving you about 2-3 minutes to read it. Anybody who's got the correct answer? Anybody can point out what's the mistake here on the storyboard? Okay, I have the first answer in the chat window. A, D, G, E, B, C, H. Well, thank you, Gajendra ji. Gajendra ji, I had not shared this with you earlier, okay? So there's no way Gajendra ji as a host can be cheating, okay? I didn't share any of the resources with him because it was all done so meticulously. Okay, so
no, I am helped by my head of the department now.
No, that's okay. You can work as a team. That's perfectly okay. That's okay. A, D, G, E, B, C, H. Okay. So I hope you can see A are killed by the antibiotic. Yes. Okay. So you start taking the antibiotic, you stop taking the antibiotic. Some bacteria are susceptible to only resistant bacteria or strong bacteria are left. Some bacteria are susceptible, which were killed by the antibiotic. Some are resistant, are not killed by the antibiotics. So thank you, Gajendra ji, for that sequence that really made it different. Now you could use this for your, to tell your students to draw a diagram. You could use this to your, general population. Can you put this in order? Very simple exercises, not involving too much of molecular biology or biochemistry, but getting them interested where they take home that there are resistant bacteria, there are susceptible bacteria. Some of them are not killed. And the next time you take that same drug, they divide, and therefore that medicine is not going to have any effect on you. Okay. So, which are, I of course discussed the tuberculosis, MRSA, and of course the ND and the non-deadly, beta-lactamase. But there are other antibiotic-resistant infections as well. Yes, they include pneumonia, they include dysentery caused by S. dysenteriae, they include typhoid, they include gonorrhea, they include tuberculosis, nosocomial infections, and more. And I hope you can see I've put the agent there. I've put the kind of resistances there. So now you cannot use penicillin for pneumonia. It's completely out. Okay. What about multiple resistances? That's even more dangerous because it's kind of, showing you the resistance to different, a lot more agents than just one agent there. Okay. So tuberculosis, I already discussed rifampicin and isoniazid. And of course, RMSA, we discussed methicillin, vancomycin, and of course Klebsiella pseudomonas are multiple resistance. Okay. Now, developing a new drug is expensive. It's not only expensive, it's also time consuming. It's not going to be done so easily. We've already seen with the COVID vaccine that coming out with a new drug is not as simple as it seems. Of course, vaccines definitely offer a much or a greater advantage than your scheduled drugs, but of course each one of them has their own limitations. So developing a new drug is not expensive. So before you ask me or give me a suggestion, Anu ma'am, why don't we look for a new drug and why don't we do that? Well, please go ahead. The timeline that it takes for developing a new drug is quite time consuming and also costly, and there are both sides of the story. So if you've developed a vaccine which is developed within 22 months or developed within 9 months or 11 months, even then people are asking the validity that, oh, the vaccine is not good, the vaccine is not efficient, we've not tested it enough. So I hope you remember, there is always a 0 and a 10. There are always those who will support and those who will completely be against, for and against. So if you take 10 years to develop a drug, it's too long a timeline. If you've developed a vaccine or a drug in a shorter time span, even then you are questioned, protocols are questioned, the methods are questioned. Nevertheless, I'm not getting into that, discussion, but this is just to tell you that this is not really a very good option because both the cost and the timeline is something that is really, really very, very unpractical. Now, essentially, why are we concerned? Because it costs us money, it costs us lives, and it undermines the effectiveness of health delivery programs. Now, that is something that I want you to take home. It costs us money, it's costing us lives, and it undermines the effectiveness of health delivery programs. Now, that is something which is, with the kind of health sector, public health system that we have, is something that should be raising a concern in you as a citizen. It is a threat to the global stability and national security. After having seen the pandemic, after having schools, colleges, and just about so many community places closed for almost more than 18 months, I can honestly tell you, as the mother of 2 children, it has seriously impacted both of them psychologically. So my heart goes out to those who have younger children or who have older children. I mean, it definitely requires a cope-up mechanism. It is not as simple as it seems that you start school, you start colleges, you start community centers, and people are going to be fine. This is going to take a toll on their mental health. And that is why I think you must have seen the government of India has invested and allowed for a community, and I think even for a national helpline. If you're on Twitter, you will see there are regular, updates coming from their desk about mental health, helpline numbers in rural Mofussil areas, in the common language that the person understands. So this is how they're extending, the mental health program, not assuming that everything is going to be fine after having been through a pandemic or a lockdown. And I'm sure you all know this is not something that we've all been trained for, but this is definitely the truth, right? So we can't afford to have another pandemic. We can't afford to have another, a lockdown or a shutdown where we say that till we solve this, we are going to keep a standstill. It's not going to work. It seriously impacts the lives and the livelihoods of people. What is the WHO Global Strategy for Containment of Antimicrobial Resistance? It's an intervention framework to slow emergence and reduce the spread of antimicrobial resistant microorganisms. And let me tell you, this has this has stakeholders, which will be not only medical practitioners, not only health workers, but also citizens. So I don't want to say that this should lead in terms of its awareness campaign as being led by citizens, but why not? Because this is something that really can be done. Now, why is it so agitated? Why is WHO saying this is a silent pandemic? As I think Suchita ma'am also mentioned, this is a silent pandemic because antibiotic resistance is one of the 3 biggest threats to human health. So it cannot be overlooked. We cannot wait for it to come, in front of us on our face and then say that, oh, I'm here. But it's something that is why the British Society for Antimicrobial Resistance and the LV Prasad, and that includes a lot of support from DBT and CCMB, that they thought that they should have this as an awareness campaign, and what better to, than depute fellows that could address students and teachers to help these taking further. Unfortunately, no amount of antibiotics will get rid of your cold. What can we do to stop antibiotic resistance spreading is understanding these basics, that it's not going to help us for a cold or for an infection that we're not sure of if it is even that of bacterial origin, okay? Which are the strategic objectives of the WHO Draft Global Action Plan is to combat drug resistance. No action today will lead to a no cure tomorrow. So that's something that I really want you to take as a tagline, take home, tell your students, tell your peers, tell your colleagues to improve awareness and understanding of antimicrobial resistance. This doesn't need you to be a medical practitioner. To strengthen knowledge through surveillance and research, to reduce the incidence of infection, I encouraged you to, your students taking up, undergraduate students taking up projects, your postgraduate students taking up projects, because when you do it, the Bloom's taxonomy says, when I do it, I understand it best. And probably that's where the way going forward. To optimize the use of antimicrobial agents, to develop the economic case for sustainable investment that takes account of the needs of all countries and increase investment in new medicine, diagnostic tools, vaccines, and other interventions. Okay. How do we carry out AMR control? Well, there are 2 attributes to it, but they're not separated. They're completely integrated, as I would say, infection control and an appropriate use of antibiotics. So what is this infection control? Infection prevention and hygiene. Having a very high hygiene protocol. I've seen colleges in Thana, Mofussil areas, Kalyan, and other areas where the toilets do not have a wash basin. If there's a wash basin, there's no water. Please get into citizen groups, stand. I usually put it out on Twitter. When you travel by the state transport buses, I travel to Dapoli, I travel to a lot of other places. I mean, there's no place to wash your hands. And we're talking of COVID times, and we're talking of AMR awareness. So these are some basic things where, you can get community help and ensure that hand washing is like a culture, that you're going out, you wash your hands. Whenever you come home from outside, please change your clothes, wash your hands and feet. I'm sorry if that sounds very traditional. I don't even want to say coming from a Brahmin family or not from a Brahmin family, but this is a protocol in my house that whenever we come from out, you need to change your dress and you need to take a wash. Okay, now this could probably have been some kind of understanding or have a religious belief, but honestly, I think it's a great practice that you just come home, you need to wash your hands and feet, you need to wear, what we call ghar ke kapde or home clothes. It doesn't need for you to be in a hierarchy in society or a particular class or a particular caste. But I think this is just about hygiene, and this is what WHO is also saying. Professional guidelines for each setting. In your colleges, in your classrooms, in your school, in where your children are. Please ensure that in parent teachers meetings and in such bodies that you put a point there that there needs to be water, there needs to be a soap, there needs to be, proper time given before eating or after a PT period to wash their hands, so that it helps or sets in a practice of good hygiene practices. Search and destroy or control and contain. Okay, now this is something which is going to be on a very war footing basis, where like I gave you an example that I never throw away the strips that I have not used in my house. I just go to the Lions Club and I donate it. So somewhere you will have to find out, stop those practices, or control and contain it. Okay, that's the only way going forward, and nobody's going to help you. By the time the government takes the intervention, we'll be there into the third pandemic. Okay, God forbid a situation like this comes again in our lifetime. Awareness and a sense of urgency, right? I hope you can see there are 23 participants, and Gajendra and his entire team, his entire college has put in so much of effort. We've shared this on different groups. We're talking to different people. But the fact that let's get it going, ma'am, we can't do it in an on-site session. We may not be able to meet people, but let's get it going. I can see the 23 of you. I am interacting with you. I can see you answering. I wish you understand that we can take this forward, and it is very, very doable. Outbreak management. Now, what if this really comes in big? What if TB resistance is the next big thing that we have to combat? What if MRSA is something that we are not teaching in a textbook, but we are combating on a war footing in our everyday lives? Enforcement by the National Health, inspectorates. We are definitely, keeping the PSAs, the Principal Scientific Advisor, Dr. Vijay Raghavan's office, communicated. We are writing a lot of projects together for outreach and its impact. But believe me, we all need to hold hands and understand the urgency of the situation. Problem, ownership, and responsibility. So I'm a teacher. I don't have to do this. I'm a good parent. In my house, this doesn't happen. No, please don't do that. Let's try and tell at least 5 other people in your colleagues, in your staff room. Take it up under your IQAC, take it up under your under your NAC protocol, or faculty empowerment programs, where you tell them that, look, next time you have a capsule or a drug remaining, please don't throw it in the dustbin. Please put it back in this box. Put awareness on priority. Believe me, it will get you brownie points, no doubt. But nevertheless, the outreach and the impact are going to be far more greater. Appropriate use of antibiotics, right indication, right dose, adequate period, lowest cost, and good quality. This is something that physicians, healthcare workers, and the consumers, us, need to together work at it. Treatment is correctly followed up by the patient. Now, I don't know if you will believe this, but this is how my mother used to treat us. If the doctor said 15 din ke baad aake milna hai, we used to drag our feet. We used to tell her, Mama, we are fine. Why do we have to go there? And no, she would take us to Dr. Bagwe. He's right opposite my house here in Chembur. And the doctor would just have a cup of tea with us, and he would say everything is okay. Please remember, if a medical practitioner is calling you for a follow-up after 15 days or after 10 days, please do not desist it as saying that he needs to make money. That's a completely different attributable parameter. But what is essential is he needs to get an update, because a lot of these doctors are linked, with the municipal corporation, and they report. They actually report, there is some kind of fever which is not getting combated with this. There is some kind of fever which after 15 days is coming back again and again. So please understand, they have a reporting mechanism, and that is why they call you for a follow-up. This is something that I was not sure, but I just did follow because my mom said it. And of course, now I know that this is how, the BMC keeps a track of different infections that are there. Bacteria causing the infection need to be susceptible. So you have to understand that this is not something that we can go into the bacteria or tell them, but this is something which is coming up as an inherent mechanism or a survival mechanism for the bacteria. Inappropriate use includes overprescription, underprescription, and prescription or over-the-counter dispensing of the antibiotic, and also giving in combination, giving 2 antibiotics at a time. What is needed is, in forms of control, is surveillance, awareness, problem ownership, responsibility. I felt responsible. I may be a fellow, but I really, it was close to my heart. So I wrote the project, and I got the funding where I can do an outreach and I can reach out to you. Professional guidelines, antibiotic stewardship, get, have antibiotic resistant fellows, get ambassadors in your colleges, and try and see how you can take this message further. This is, of course, combating antimicrobial resistance is by, you can see, community services, community services in just about all the fronts. That's going to help reduce unnecessarily antimicrobial use, bacterial resistance surveillance. Please report, do a regular follow-up, controlling environmental pollution, intensifying sewage treatment, screening and intervening of MDROs, multidisciplinary antimicrobial intervention, exploring the mode of antimicrobial stewardship, developing new antimicrobial drugs, peptides, and phages, maintaining the balance of microorganisms in the human body, correcting the immune imbalance at the right time. Okay. And this is the way going forward. I've just tried to put it up together. This is again from one of the WHO desk slides. Well, transmission, as I said, I did not want to take just half a part of this because that involves or engages humans. I hope you can see as animals take antibiotics and develop resistant bacteria in their guts, it goes through poultry and then it goes through handlers and through improper cooking that is occurring. And that is how I hope you can see the two arrows that are going to the human population. Please do not disregard this. Do not overlook this. This is not something jo baad mein dekha jayega. This is something that jo abhi kiya jayega. Okay. Fertilizer or water containing animal feces. Now see this. When this is going through, effluent treatment plants and it is again used for, being circulated for watering the crops, then again it gets into what we call as the food web or the food cycle. So next time you pass the TB hospital at, Sat Rasta, please just don't look at that. Please look at your own self and say, what have I done to ensure that the AMR has gone down or is going down? Even if you can spread this awareness, it's going to be very, very essential. This is again borrowed from the PNS strategy where they're combating, I hope you can see, antibiotic resistance, a globally integrated strategy that includes antibiotics, vaccines, diagnostics, antibodies, and new tools targeting the host, the microbiome, or delivered by phages is required to fight AMR effectively. I don't know if you really feel proud or you take a sense of belonging to a country called India, but I truly do. When I got this fellowship, which is 1 lakh rupees, and believe me, I was so overwhelmed. I'm not telling you the money because I thought it's important, but because I thought I fully deserved it. But what I want to tell you here is that a small a third world country, an underdeveloped country where CCMB, DBT, LV Prasad Eye Hospital come together and say that no, Anupma, we should work towards AMR, is canvassing at the PSA office that AMR needs to get more footage. We need to get more projects. Somewhere it tells me that this is my Azadi Ka Mahotsav. This tells me that yes, I'm celebrating independence. I'm celebrating a new India, which gives wings to combating something which is going to be a third pandemic, is putting up, opening its eyes that no, there's something that we need to do, there's something that we need to take action, spread awareness about, and is motivating and ensuring that this message reaches our people. So today, definitely for me, is a big day, and I'm so thankful to all of you because this is one of my first workshops in these fellowships. And I'm so sorry to share that I lost somebody in my family, but I just didn't want to kind of give this up. So please bear with me for that. So with those few words, I'm just using the last few slides, which I've taken from Twitter from Satvik, where we are in the middle of a pandemic caused by the spread of a virus. There has never been a better time to improve our sanitation and hygiene practices in the first, to reduce the spread of infections in the first place. The most basic changes we make in these practices today can play a huge role in securing a healthy tomorrow. Not doing this could have serious ramifications for, far worse than what the COVID pandemic is. This is Satvik Venelaganti, who was one of the workshop participants when we were doing the pilot workshops, and handle antimicrobials with care. Thank you so much for being such a learned and patient audience. I really feel so overwhelmed that, at a moment like this in my life, I'm still there talking to you and being there for you. Thank you very much. This, of course, is Jyoti Joshi from CDDEP, where antibiotics should not be a substitute for poor sanitation and hygiene, unsafe drinking water, lack of primary care services. And, a precise, rapid, and accurate diagnostic service, or even good logistics and supply systems for quality assured antibiotics and vaccines is what we are looking forward to. So thank you very much for being such a patient audience. I will just share the link of a very exhaustive quiz that we have put together. This has been put together. Sucheta ma'am, I must tell you, Gajendra has, kind of stood shoulder to shoulder with me. Kandhe se kandha milakar unhone kaam kiya, and I hope you will give us a feedback on the form that we've put together with the questionnaire. I hope you really enjoyed this session, being part of it. And since it's one of my first sessions, I'm really, really welcoming any kind of feedback that comes from your test. Just give me a minute. I will just start the screen and I should be able to share the test with you. Yeah. Yeah, just give me 1 minute. I will just share the test with you. If there are any questions, I would be happy to address the questions. Yeah. I'm just putting this in the chat window so that you can, the link may not work over here. You will have to copy the link. So I would appreciate if you can just copy the link and put it, in another window. And I will, Gajendra ji, I will share it with you in email also and on WhatsApp also immediately, so that in case somebody is not able to open the link, because many a times the Google Forms, it's a program clash. It may not open in Zoom, okay, because when you're clicking it. So please copy this link and do it as an independent window, and you will be able to navigate through the test. Thank you very, very much for being such a wonderful audience and such a patient audience to bear with me. Thank you so much, Gajendra ji, and to your entire college for having facilitated, and a huge round of applause, because I think I went to so many colleges and yours was the first one who said that, no, Anupam ma'am, we have to hear you out and we have to, be together in this. And I really hope that a lot of you will take this AMR further in the programs that you already have in your college, under IQAC, under NAC criteria, or for student empowerment or for faculty empowerment. And, that will be like, an award for me that, yes, you have taken the program further. And Gajendra ji has very interesting activity, to end here. So over to you, Gajendra ji. If there are any questions, I would be happy to address. Yeah, thank you so much.
Before I proceed, I would like to ask the participant if you have any queries for Dr. Anupam Herschel. You can just type it, or you can just unmute yourself and you can ask it here only. Meantime, I think we will proceed for the last portion of this event, that is the vote of thanks. I'm extremely thankful to Dr. Anupam Herschel. We were talking feedback, and she really had a great loss in the form, one of the very close ones she has lost during this 2-3 days back. And we were continuously in contact, and we were discussing about how to organize this thing. Today also she was supposed to join by 12:10, but then there was some technical difficulties from our and her side also, so we were unable to do that thing. But at the end, the result was very enlightening. I think she is a true warrior. She has taken this AMR thing to the next level. And so far, we were only considering bacteria or this microorganism was just as a small microorganism, but the battle is on, and we need to avoid the collateral damages. So that is how we can proceed further, and we can just spread this word of awareness into the communities, as rightly said by Anupam Herschel ma'am. I'm very much thankful, ma'am. You have managed to come very strong. You are a great inspiration, and I must mention here that there are many fans of you in Amravati. One of that is me and our IQAC coordinator, Dr. Sushita Khorke madam. And we all in Amravati are eagerly waiting for your lectures, whether it is offline or online. We are always there to welcome you. Unfortunately, we didn't have this kind of a where we can hear you offline. But still, we have managed ourselves to hear you online. It was again a pleasure listening to you. I must not forget to mention that the IQAC coordinator, Dr. Suchita Khorke madam, she instantly just agreed to this, and she was like, "Ki nahi, hame ye talk rakhna hi chahiye, because this is very novice." And she's always Bilkul. She's always for this particular thing that we need to organize such very innovative thing, because we being at the rural background, our is a great responsibility to spread this word and to understand all this kind of thing that is happening all around in the big metro cities, and we need to cope up with the pace of those particular cities as well. I must also thank our principal, the president of today's event, Dr. Alka Bhise madam. She was also very supportive for this particular thing. Unfortunately, she was unable to join because she is also suffering from some.
Gajendra ji? Gajendra ji? I think we have some network issue at sir's end. We'll just wait if we.
Yes.
Yeah, thank you, sir. Thank you so much. Yeah.
Yes, ma'am. I'm again. Yeah, I'm back.
Thank you so much.
I'm back.
Yeah. I think we're all in exceptional circumstances, so we completely, accept it. Yeah. Yes, sir.
Yeah. So I thank once again, and most importantly, I would like to extend my thanks to the audience, because they have been a very patient listener and they have waited long, and they are a great sport here. They have understood the concern of the particular topic. They have helped a lot. I would like to share here the last portion that we have also organized a meme making competition. The competition is basically based on the topic that Dr. Anupam Herschel ma'am has covered today. So I have made a special WhatsApp group where I'll be sending all the information related to this meme making competition. And here particularly, I'm sharing the feedback of this particular program. All those participants, those who will fill the feedback form, will definitely get the certificate. Just allow us a week of time, and then you'll be getting the your certificate of participation from particular through email only. I'm once again thankful to Dr. Anupama Herschel, ma'am. Thank you very much, ma'am. Thanks
for the great session. Thank you. I have spoken to BSAC and to LV Prasad Hospital. They were very happy with the memes. So I will be officially sharing the memes on Twitter, one each day with an anecdote. So a lot of you are going to get a lot of mileage. So if you haven't yet joined Twitter, please do. And if you can put your videos on for a photograph, we can have a group photograph, which we can use for the purpose of records, only if you're comfortable. Yeah. Only if you're comfortable.
Yeah.
Thank you, Sucheta ma'am. Thank you so much for having facilitated this session. Thank you, Dr. Preeti. Thank you so much.
I would like to request all the participants if you could switch on your cameras for a while.
Rajendra Singh, yeah, your camera. Yeah, thank you. Thank you so much. Thank you so much. Yeah. So with your kind permission, sir, a warm note to your principal, to your entire management and staff. I will take your leave. I hope we've not missed out anybody in the photograph. I'm just taking a few more photographs so that we can, use it for the purpose of records. And I hope there are some take homes. And if there are any suggestions, I really welcome it from my desk. Thank you very much once again for this wonderful opportunity to connect here.
Thank you. Thank you very much. With your kind permission, ma'am, should I disconnect the meeting?
Yeah, sure. We can put the meeting to an end. Thank you, sir.